Okay, well, this video is going to cover Chapter 7, which is on a pretty important topic for the macroeconomist, and that is the topic of economic growth. So here is the image that is going to start off the chapter. And the way you want to interpret this is you've got countries listed on the top of this spectrum, and underneath you have listed the average calories consumed per day. And so what we see is that countries that have high rates of economic growth are also ones that can afford things like high levels of food or access to food, whereas other countries, and some of these are so minuscule I can't even see them, really, those are characterized by countries that don't really have a high level of calorie intake. So that's one, one real high level characteristic of an economy that's growing is, hey, are the people able to afford to eat calories? All right, so the topic of modern economic growth is that's the one. When people say economic growth, what they're really referring to is the modern economic growth period, which happened around the beginning of the Industrial Revolution onwards. Why? Because prior to this time period, there was not much action when it came to economic growth. You almost think of the period as like you've got prior to 1870, GDP was pretty flat, and then all of a sudden 1870 happens and the Industrial Revolution happened, and then GDP kind of skyrockets. So that's ultimately going to be the historical event that set this up, and we really want to get to know, exactly what did this mean and how did it contribute towards economic growth. So speaking of the Industrial Revolution, the definition of this is the widespread use of power-driven machinery and the economic and social changes that resulted in the first half of the 1800s. So we've talked about capital before, and there's obviously farm equipment, and people they've always used tools to get the job done, but that's different than having a very large, let's say, for example, a factory that's next to a body of water. So once upon a time, maybe it was, the river outside of the factory, there was a paddle, and that's where they got the power from. But now with the advent of the steam engine and other technological discoveries, that blossomed into huge amounts of productivity gains. And you had the railroad system put in place, and all of these things. There was a lot of action happening around the Industrial Revolution towards what we call the Gilded Age as well. In fact, lots of the mansions we have in Newport are the summer homes of a lot of these industrialists who sort of led the charge on this. All right. So here are just a couple of statistics for you. So in the 1870s, the GDP of the top economies in the world was 2.4 times the GDP of the world's poorest economies, and this is on a per capita basis. But then if you fast forward to 1960, this is just 90 years so less than 1 century. You can see that that gap has absolutely increased. It's almost doubled, right? So in 1960, the top economies had 4.2 times the GDP per capita of the world's poorest economies. Okay. Okay, so when we're talking about economic growth, we need to understand what are some of the necessary requirements to have growth occur. Okay, And so if you peel all the layers of the onion away, all of the steam engines, all of the those other inventions, you really can't have innovation and inventions unless you have these two characteristics here, or these two institutions. One is the adherence to the rule of law, and the other is the protection of contractual rights. All right. So here, the rule of law is essentially everyone has a set of, individual rights that are protected, the right to their lives. And we need those laws to be enforced. If you have laws on the book that aren't enforced, what good are they? All right, if no one got pulled over and got speeding tickets, do you think everyone would still drive 50 miles an hour on the way to Boston? Probably not. All right, so we need laws to be clear, public, fair, enforced, and applicable to all members of society. And contractual rights kind of comes out of that. So this allows people to enter into agreements with each other regarding the use of their property. So this is almost like not just for economic growth. This is like a prerequisite for you to have even like an economy where people are exchanging with each other. Something as simple as coming up with a contract to make a purchase with someone. This is required. We require contractual rights, because if people violate their contracts, we need to have the ability for individuals to seek recourse through like the courts. Okay. Because we don't want people being taken advantage of only because they're weaker than someone else. So we don't want physical power actually dictating what happens in the economy, because that's not not the best use of our economic resources. Really, we need the rule of law, and we want contractual rights that are enforced. So a little bit more on contractual rights. The other thing, it's required for invention, because think about a scientist who comes up with a new invention. They need the ability to patent that invention so that no one else can take advantage of it. All right. If you don't allow for patent systems, or like trademarks, patents, but patents most importantly for the protection of intellectual property, then maybe some of your best and brightest scientists who come up with good ways of creating inventions that lead to economic growth, they might leave your country and go to a country which does protect their intellectual property rights. And that's something called brain drain, and it's happened to some poorer countries. And so one of the best things that we can export out to the developing world to assist in their economic growth is a system of the protection of intellectual property. Right? So that's not to be underscored, or that's not to be underestimated. Right? Okay, a little bit more here. So worker productivity here is the key. Okay, and it is defined as labor productivity. That's the vocabulary word here. And that is essentially the value of what is produced per worker or per hour worked. So we can think of it in two ways. So let's see if we can write this out. So we can think of, if we have output, we can think of it as output right here. Let's say GDP per worker, or we can just say GDP. Let's say everybody in the economy is working. So we can write that out as GDP per population. So that gives us a sense of GDP per capita, and that might give us it's a proxy, or it's approximately, close to labor productivity. But what we might have a little, and so obviously this is something that is kind of easy to calculate. You just take GDP divided by your population. So that gives you an idea of produced per worker if everybody in the economy is working. The other way you can do it is, let me erase this real quick. The other way you can write it out is you can do it as, like, let's say GDP, right, And then we divide it by the total number of hours worked by everybody in the economy. So that gives you a sense of, like, like miles per hour gives you a sense of the speed a car is going. Well, GDP per hour worked would give you a sense of how much production on average is happening every hour of the day. All right. So those are both equivalent. I don't want to say equivalent, but they're pretty good definitions of labor productivity. All right. So what determines labor productivity or worker productivity? It's two things. Well, three really, but these two are the most important: human capital and technological change. Okay. So human capital is that is essentially, it's like your brain, really. It's the accumulated knowledge. So this is for the entire economy. The accumulated knowledge from education and experience, the skills, expertise that the average worker, put average here, that the average worker in an economy possesses. Okay, so the human capital, it's not like physical capital. Physical capital is that, the equipment that people use to make output. Human capital is, you want to think of it as like their the experiences, the skills that they use to make output. Okay. And technological change, that is something that's also utilized by labor to increase their productivity. So this has two margins. One is invention and the other is innovation. So invention is you come up with a completely new way of doing something, and that advances the envelope of knowledge. Okay, so you come up with an entirely new technique, and then innovation is, well, I'm going to take something that's currently existing and I'm going to make it even better, or I'm going to improve upon it. Okay, so that is putting advances in knowledge, so putting inventions that are already there to a use in a new product or service or some new way of utilizing pre-existing inventions. So either one of those are good. We want people to come up with new inventions, but we also want people to come up with new ways of using the old inventions as well. So either one of those two will help when it comes to technological change and its impact on worker productivity. And then economies of scale, that is where if you've got large factories and larger industries, the larger they grow, they tend to make individual workers on average more productive. And we call that the economies of scale, but they do reach a point where if things get a little bit bigger, productivity starts to decrease because of the constraint that communication plays. All right, so if an organization gets too big, then delegating responsibilities and communicating to your workers gets a little bit more complicated, and that has a negative impact on productivity. So how are we going to model all of this? We have something referred to as a production function. So you want to think of a production function as you've got this little black box. It's a machine of some kind. It's our production function, and into the machine go inputs, right? Inputs. And out from the machine comes GDP, or output. And that is our production function. And we've got two focuses of it. We have, let's say, a microeconomic production function. So that's, you can think of this as an individual firm. So instead of GDP, it'll be something like donuts if we're talking about LaSalle or bakery items. But for the entire economy, it's going to be all of the economy's inputs going into this production function, and that's where we get GDP from. So in macroeconomics, we call the connection from inputs to outputs for the entire economy an aggregate production function. So the way I've written this out, this is an aggregate production function because we're producing GDP out of it, right? And so this is the process whereby an economy as a whole turns economic inputs such as human capital, physical capital, technology, and inputs into output measured as GDP per capita. Okay. So on the left here, we have the aggregate production function. So you can see here we have the workforce, we have human capital, we have physical capital, and technology. So all of these are the inputs that go into the production function, right? And as we said, GDP is the output. But then if we want to write it as GDP per capita, because again, remember, this is the most accurate measure of the standard of living, so we want to use GDP per capita. So how do we define that? Well, if you look up here, all we really did was we took our workforce, we divided everything by the workforce. All right, so let me put WF for workforce, WF for workforce, divide W by WF, and divide it by WF. And what we do to the left-hand side, we have to do to the right, so we divide this by WF as well. And assuming the population and the workforce are the same, we get, this is the result right here. You can see it's human capital per person, so human capital per person. We have physical capital per person, physical capital per person, and technology per person, technology per person. And that gives us GDP per person, or GDP per capita. All right. Workforce divided by the workforce, this kind of cancels itself out. It's equal to 1. So in a production function, that just falls out. And we get what we want. So what's important for economic growth, or the growth, what's important for the growth of GDP per capita, using this logic here, is we have a couple of sources here for increases in GDP per capita. We can increase human capital per person. So for instance, send people to school, make public school cheaper, make universities affordable. We can increase physical capital per person. So we want more investment to happen for businesses. So maybe we'll make it favorable for businesses to start investing in their workforce. And we want technology per person to increase. So we want the government maybe to sponsor research by the NIH or by other university systems. You know, the public university system is paid for largely through tax dollars. And so that's one of the ways we can try to increase technology per person, is by funding these things. So you notice we want, these things have positive benefits to them. So we do want these things to happen. So it might help if we subsidize them with tax dollars. Right. So let's look at speaking of growth rates, we want to think of how are we going to talk about this. So the rate of productivity growth, all right, and again, productivity is that labor productivity. It's output per hour or output per worker, right? This is closely linked to the growth rate of GDP per capita. So again, if labor productivity is the name of the game, then if we increase labor productivity, that's going to enable us to have GDP per capita grow over time. And we already defined this, but it's worth recalling. So a common measure of U.S. productivity per worker is the dollar value per hour that the worker contributes to the employer's output. So we can think of that as the let me write it out, as the GDP per hours worked, like we did before. But we want to know, what is this on a per worker basis, right? Because obviously if you take the entire economy's GDP and you divide it by hours, you're going to get a pretty big number. And it's going to be like, well, our workers aren't that productive. So you're going to take the number of workers as well, and then that'll give you an approximate value of what this definition says. It's going to be the dollar value, so GDP per hour, hours, that the worker contributes to the employer's output. So you divide it by workers, and you get that that measure there. All right, so this will exclude government workers and farming. Government workers primarily because there's no marketplace that government services are exchanged in, and farming primarily because it's such a small sector of the economy that almost trying to find data for it is, at least accurate data doesn't make, it's very difficult. All right, here's an index for you. This is output per hour, okay? So it's not, 20 units of output per hour. There's usually a base year here, and if we drew it across, I'm guessing it's 2012 again, so, or somewhere around there. Yeah, probably 2012. But you can see here output per hour has steadily risen over from 1947 on to 2020, almost like in a linear fashion. And this is largely through increases in all of those inputs that we talked about. Human capital per worker, physical capital per worker, and technology per worker have all increased, contributing to this rise in output per hour worked. Right, this is our labor productivity measure. Although it hasn't been completely equal in terms of the growth rates of this, right? So between 1950 and 1970, the growth rate was somewhere around 3.25. So productivity grew on average every year by 3.25%. In 1971 to 1990, it fell a little bit down to about 1.9%. And then during the dot-com era, 1991 to 2000, it rose again back up to somewhere around 2.3%. And then, since then, we've sort of stabilized back down to around 1.9 to 2%. This is kind of what we expect to see, but there has been a bit of a downward trend here. Okay, and that's kind of, I don't want to say to be totally expected, but if you think about manufacturing following World War II, there was a lot of productivity gains to be made. And once those productivity gains were made, it kind of becomes harder to reinvent things like that. And so we sort of see maybe less technology and more innovation occurring over time. And technology, by its very nature, it results in higher levels of productivity than innovation does. But innovation is very, very important as well. All right, so let's look at what compounding a growth rate will do for GDP. So here is the formula that you're going to want to focus on. All right, it's right here. It's in your textbook as well. But this is what we're going to use to calculate what growth rates are. All right. So here we have a starting point. So we say, what's GDP right now? All right. Let's say GDP right now is, I don't know, $100. All right. Then we have the growth rate of GDP. It could be 10%, 5%, 2%. We have to do 1 plus that growth rate. And then we bring it up to the power of the number of years we're talking about. And that tells us at the end of how many years we have, what GDP is going to be on that point. And this assumes that the growth rate is constant. So here are a couple of examples. So let's say that the growth rate is 1%, and we have an original value of 100. So that's this GDP at the start date is 100. So in 10 years, at just 1% growth, you're going to get 110 in 10 years, all right? Starting with 100. So that's a 10% increase over 10 years. And now if we go to 25 years, you go from 100 to 128. And then if we go into 50 years, starting off at 100, you're going to go up to 164. So let me see if I can write this out. So we're going to start with 100. And it's going to be 1 plus, and we said it's 1%. So that's 0.01. All right, that's 1%. To the 50th power. And that equals 164. Okay, so that's just with 1%. which is a very low number actually when it comes to economic growth. We said it was closer to 3% in the United States, 2% more recently. Now look what happens when we go from 1% to 3% to 5% to 8%. It's not much difference here. We go up by 2%, up by 2%, up by 3%. But look what happens to these values over the course of 50 years. So let's start with 5%, let's say. We could skip over 3%. So if we go with 5%, the same amount of time going by, 10 years, all right, with an original value of 100, you end up with 163, which is close to what we got out of 50 years at 1%. You could do that in a mere 10 years, all right, if your economy is growing at 5%. And then over 50 years, that becomes 1,147. From that original value of 100, in 50 years, you get 1,147. Now, if we're talking about 8%, which is a high rate of economic growth, a very, very high rate, in 10 years, you have 216. But after 50 years, look, it's 4,690. That is a huge increase over this 164. You can see this is, we're talking just a 7% difference in the growth rate of the economy, but it results in profound increases in that value. So one of the theories as to why some of these countries are so poor, it's not because they're just that much poorer than we are, but they haven't had a chance to grow at the same rate of economic growth we have. All right, and that makes, as you can see, over the course of 50 years, which is not a very long time in terms of human life, it's half a lifetime. You can see that it makes a huge, huge difference. So you get a couple of generations through, you can see how one country can become very, very rich, right, and another country can stay pretty poor. And this is called compounding the growth rate, right? Because we're going from one year to the next, and one year grows, and then the next year is including the growth from the previous year, and then that growth itself starts to compound. All right, so that's the rate of growth when multiplied by a base that includes past growth in GDP. All right. So here's an example. If South Korea had GDP of $2.2 trillion with a growth rate of 2.8%, we can actually forecast what future GDPs are going to be. And all we have to do is start off in first year, second, third, fourth, and fifth. And we start off with $2.2 trillion. And each year we multiply by 1.028. And we get 2.3 trillion for the first year. That's the starting amount. That's the starting value for year number 2. Again, we multiply by 1.028. And we get a little bit more than 2.3 trillion. That's the beginning value for the next year, and so forth and so on. The one way we can go directly from this starting value up to here, maybe you can do this in your head, but we can just write it out using our formula. All right, and that's just, let's put the dollar sign there. It's 2.2 trillion. Let me put the decimal, 2.2 trillion times, what's the growth rate? 2.8%, so it's 1.028, and it's 5 years, so to the fifth, and that should equal 2.5 trillion. That's all that's saying. But here, this table here broke it down into each individual step. But you can see here we're multiplying every year by 1.028. We've done it 5 times. So that's like 1.028 to the 5th power. It's the same thing. All right. But this table just breaks down that growth to you. All right. Okay, so there's components of economic growth. We've already talked about physical capital, but let's have an official definition for it. So that is the plant and equipment that firms use in production. So this also includes infrastructure. So don't forget, that's our freeways, public transportation system. Just because you have workers or a lot of workers in the economy, those workers do need to show up to their jobs. And so there's a number of ways that they do that. One is by using their personal vehicle, so they do need a highway. And the other is by using public transportation, like the bus. So they do need public transportation. Those are all infrastructure. So increases in the quantity will help. So if you just have more physical capital, that would be good. Also increases in the quality. So if you have physical capital that's more technologically advanced, that would help too. All right. And again, we talked about human capital as well. That's the collective skills and expertise and experience of workers, education level too. And then technology, let's define that. This is all the ways in which existing inputs produce more or higher quality, as well as different and altogether brand new products. It's an interesting definition. All right, capital deepening is if we take capital per hour, capital per person. So let's say if capital is capital K, and we divide it by, let's just call it the population because that's just an easy abbreviation. All right, so this is capital per capita, okay? And if this number increases, that is referred to as capital deepening, all right? When society increases the level of capital per person, hopefully it's not done by decreasing your population. Hopefully it's done by, increasing the capital stock at a higher rate than your population's growing. All right, and this applies not just to physical capital, it's also applying to human capital. So this would happen, for instance, if more people got a higher level of education. So here's an example of capital deepening, and this is human capital now. So we can see we're going back to 1960 all the way up to the near present, and you can see that this is the proportion of the population 25 years and older who have had college education or more. So in the 1960s it was around 10%. So 1 out of 10 people who were over 25 years old had a college education. But you can see that that's almost it's up to 40% now. All right, so that's gone up a lot, right? And what might be a little bit more extreme is high school. Surprisingly, back in the 1960s, only around 60% of people that were 25 and older actually had a high school education. All right. But then as of now, it's almost 100%. Okay. These are both education, so that would be an example of human capital deepening over time. What about physical capital? That's had a pretty large increase as well. So back in the 1950s, it was somewhere around, 100 and I don't know, where would we put that at? $175,000 per worker. On average, a worker had $175,000 to their name as far as the equipment they had. And this could be, not just the value of the factory that they're working in or the equipment that the, job let them have, but it also includes the infrastructure and the economy as well. And that has grown in linear fashion, and it's kind of flattened out a little bit as of 2005, 2010, 2015, all the way up to almost now. All right, there's a plateauing there. But other than that, it's grown, with a linear trend. In all honesty, I'm not sure what this is about here. That's a curious thing. I got to figure out what the answer to that is. Okay, now let's switch gears to growth accounting. And so we can look at an economy's growth and try to figure out what is responsible for that growth. How much of it was technology? How much of it was labor? How much of it was capital? Okay, and that's essentially what a growth accounting study does. Is it looks at economic growth from the perspective of an accountant and tries to say, all right, what was responsible for what here? Okay, so that to determine the extent to which physical and human capital deepening and technology have contributed to growth. All right, so technology is clearly the most important contributor to U.S. economic growth, according to these growth accounting studies. You can have population growing, you'd have capital growing, but if you don't have technology growing, you're not going to get any economic growth. All right, because growth in human capital and physical capital, that's only half of the picture. Okay, all three of these need to happen in order for us to be successful here. So how do we create a healthy climate for economic growth? Well, as I mentioned, we want the government maybe to subsidize those areas with which we think will exhibit high levels of return for society. So here's one way we can facilitate capital deepening and technology is we invest in education. Savings and investment will lead to higher levels of capital. Infrastructure, so the government building better freeways, better bridges, that's going to lead to a higher level of labor productivity as well. Special economic zones doesn't really apply to our country here in the United States, but a country like Hong Kong, for instance, that would be very important for that. So that's an area of a country usually with access to a port where, among other benefits, the government doesn't really tax trade. All right. And then scientific research. This is very, very important. You have the government allocating tax dollars for grants to run research labs to do things like vaccine research, nuclear power research, energy, stuff like that. It's very good. Okay, economic convergence is this idea where if you've got a country that has a low GDP per capita, eventually it will catch up with economies that have high GDP per capita because those countries with low GDP per capita tend to grow faster once they start growing. So here's some data for us. So if we look at the high income countries, the average growth rate of real GDP between 1990 and 2000 was 2.7% for those high income countries. And then, more recently between 2010 and 2019, it was at 1.7%. But when we look at the low income countries, they grew at a higher rate. All right, 3.8% between 1990 and 2000, and then 4.5% between 2010 and 2019. So here we see that's almost a 3% difference. And that 3%, like we saw in the previous table, could actually account for a lot. And then we also have the middle income countries. They are the ones that seem to be growing the greatest, actually. So this is interesting. But something happens here. So some of these middle income countries might actually take on the look of a low income country. You can see that the middle income country went from 4.7% down to 4%. But what that tells me is maybe some of these middle income countries are becoming a little bit more, they're close to becoming high income countries. And what happens when those economies start to grow is that the growth rates start to decrease. So when you've got a very, very, very large economy, something like the United States, the United States economy only grows around 2% per year. Now that's a huge amount of growth if we're talking about $24 trillion. But for a small economy like that of Uganda, for instance, having that economy grow at like 5% per year is not out of the question. Having China grow at 8%, 9% per year for, about 10 years, that's not out of the question either. So we kind of see this happen in real life, but the evidence is sort of mixed on that. But here is a nice snapshot of some of those. So here it says middle income countries have GDP growth that is faster than that of the low income countries, and then low income countries have GDP growth that is faster than that of the high income countries. So interesting look there. So here are some arguments that favor convergence. So here, it isn't 100% certain that this happens. So there are arguments for and against. So here are some arguments for it. And that is that, there could be this issue of diminishing marginal returns. So again, that's as an economy starts to grow and grow and grow, you're not going to see the same return to your inputs as you did when you were really, really small. All right. So you want to think of it as like, if you've ever learned to drive a car, that when you first started, you were learning a lot. It was almost like too much information. Okay. When to turn signal, when to look over your shoulder, who goes where, who has the right of way, right? So you're making lots of gains there. Okay. But over time, you become a better driver. But you're not learning as much to the same rate as you were when you just started off brand new. Or if you're somebody who's like a gym rat and you go to the gym and work out a lot, you notice that when you first started working out, you make all these tremendous gains. But then you start getting bigger and bigger and stronger, but you're not making the same level of gains or, the rate of gains that you were when you first started working out. That's kind of to be expected, right? And this is essentially what we call diminishing marginal returns, right? So low-income economies could converge to the levels that the high-income countries achieve if we believe that there is this diminishing marginal returns. And these low-income economies have the advantage that some of the technologies they use have already been invented. All right, and this economist here laughingly calls this the advantages of backwardness. All right, so if you're a small, tiny developing nation, you can use the inventions already that these other large economies have already used. Things like the steam engine, nuclear power. We've been using that stuff for the last 50 years. So, we give that technology to a poor country. They use it. They didn't have to invent it. They just kind of get it given to them, and they can grow. That helps convergence as well. And low-income countries have the advantage of being able to see what works and what doesn't. So they have observed the experience of those that have grown quickly, and they've learned from it. All right. Here are some arguments against it. So, will technology improvements run into diminishing returns over time? So this doesn't seem likely because there's the application of new technologies everywhere and widely that has really low marginal cost. So, if we're talking about technology or knowledge, it's not like one person uses that technology, no one else can, right? So if I just shout out, hey, what's 2 plus 2 equal to, right? That's an idea. 2 plus 2, everyone can use that idea. 2 plus 2 equals 4. But if we're talking about like a contact lens, or if we're talking about a piece of equipment, that's different. Only one person can use that at a time. You can't like share equipment largely, right? But we can all share ideas and technologies in our mind, all right? So there is really, really low cost to applying that stuff broadly. And even if you do have new technologies, the increase in performance is not necessarily guaranteed because you still have to be able to utilize that technology. What good is having this technology if you don't know how to implement it, right? So low-income countries may have those opportunities to copy and adapt technology, but if they don't have the supportive economic infrastructure to take advantage of that stuff, well, what good is it, right? It has no relevance. So these are a couple of arguments against it because we can't really assume that countries can look at what's happened in a positive way or negative way in other larger economies and say, oh, we're just going to copy what they did, because they might not even have the infrastructure capable to implement those things. So here is there's a nice little graph here that really illustrates what we mean by capital deepening and new technology from a graphical standpoint. So here, let me show you in a separate graph what that thing is trying to illustrate, because it might be a little much to look at it there. So I'm going to draw a separate graph over here. And so here we have capital. I'll put a K there for capital. And then here we'll put output per capita, and I'll put that as, I'll just call it Y per population. But technically, this should be also K per population if we have Y per population on the Y-axis. And we have this production function. Okay. So why did I draw that production function like this? Well, because we have, again, diminishing marginal returns, so we can't just grow at a 45-degree angle continually. All right, we can only increase capital so much. What we do need, though, is increases in technology. So here, what this shows is, well, we can start off at a capital level here, okay, and that gives us this level of output here, okay, which translates to that level of GDP per population. And then we can go and increase the capital way to over here, and that gives us this level of GDP per capita over here, right? So this is if technology does not change at all. So the only thing that we changed was we increased capital from here. We increased it out to here, but GDP went from here up to there, right? GDP per capita. Now, if we increase our technology, we can actually make a whole new production function. Because again, remember what technology does. It enables us to take the existing inputs and make more output with the same amount of input. So that might give us a whole new production function, right? So instead of just going like from here to here, what this increase in technology allows us to do, so if we increase our technology while we're increasing our capital, we can actually move from here, right? We could actually move up to, we can jump up to there, right? Because on this new production, so here, if we take this path from here to here, instead of continuing on the old trajectory with the old technology, if we have new technologies, that will enable us to go from here on up to the new level of output per capita, which is somewhere in the vicinity of way up here, right? So it's almost double. And that's what, that's how you want to read this graph, right? And, again, it's a great graph in your textbook. The footnote underneath the graph illustrates that graph pretty well. And I'll probably go over it on the supplemental video with the exercises. All right, so that's all I had for this chapter, and I'll post the other video with the examples, and then hopefully that'll help you guys out a bit. And as always, reach out to me with any questions you have. All right, thanks.